Okay, how many kilojoules of heat are required to change 15 grams of ice at -10 to liquid water at 70? So the first thing that you want to do is to draw a phase change diagram. And so you just have to memorize it. You have to go up, over, up. Okay, now you want to mark where you're starting. So we're starting at -10, so we'll just pick a spot right there. We'll call that -10 degrees Celsius there. Okay, so now the water is going to warm up and we're going to stop at 70, but something important happens right at here. This is 0 degrees Celsius because that's where the ice will melt. This will be 0 here. Then it will warm up to 70 right here. So you want to mark those spots on the graph. And you can see that you have 1, 2, 3 segments on the graph. That means you're going to have to do 3 different problems. So problem number 1, you have to figure out how much heat it takes to warm the ice up from -10 to 0 where it will melt. So you're going to use Q equals mc delta T. Wherever the graph is slanted, you're going to be using the Q equals mc delta T. Okay, now you plug in the numbers that you need. So we're going to plug in 15 grams for M. Okay, now the specific heat of ice is 2.09 joules per gram degrees Celsius. And the temperature change is going to be the final temperature, but that's just for segment 1, which will be 0 minus -10. So that's going to make your change in temperature be 10 degrees Celsius, because 0 minus -10 is 10. Okay, so then you multiply all that out, and you get that your answer equals 313.5 joules. But you want to divide by 1,000 to change it to kilojoules, so you're going to move the decimal 3 spots. And so the heat that's going to be required to warm that ice up is going to be 0.3135 kilojoules. Okay, that's step 1. Okay, step 2, we have to melt the ice. So we need the energy from this point at 0 degrees Celsius here, so ice at 0 here, to liquid water at 0 here. So this part is going to be a picket fence type of a problem using the heat of fusion. So what you do is you start off with how much ice you have, the mass, which is 15 grams. So you go 15 grams of water. You have to change that to moles, so 1 mole water equals 18 grams of water. Okay, that's the molar mass. And then you're going to apply the heat of fusion. So for every 1 mole of water, it takes 6.01 kilojoules to melt 1 mole. Okay, you multiply all that out, and that happens to equal around, let's see here, about 5 kilojoules. So 5.0 kilojoules will be close enough. Alright, so that was step 2 right there. Let me put step 2 there. Okay, now step 3, we have liquid water now, so we have to warm the liquid water from 0 to 70. So when the temperature is changing, you're going to use Q equals mc delta T. So this is going to be step 3. So Q equals the mass of our water, which is 15 grams, times the specific heat, which is 4.18 joules per gram degree Celsius. Notice that the specific heat of liquid water is different from ice, okay? So you got to keep that in mind. And we're going to take that times the temperature change from 0, or 70 minus 0. So 70 minus 0 is 70 degrees Celsius. So then we take 15 times 4.18 times 70, and that equals 4,389 joules. We'll move the decimal 3 spots to change to kilojoules, so that equals 4.389 kilojoules. Okay, now we've done all 3 steps. The final step is to add them together. So we'll take step 1, which is 0.3135 kilojoules, plus step 2, which is around 5.0 kilojoules, plus step 3, which is 4.389 kilojoules. If we add all that together, we end up getting around, if we just go to the nearest tenth, 9.7 kilojoules. So the answer for this problem, to go from -10 to 70, it would take 9.7 kilojoules.